This is Log Basic Notes. You'll need your notes handout to go along with this, and during the video I'll stop at various times and have you do some problems, pause the video, and then check your answers. In its basic form, a logarithm is an exponent. What exactly do I mean by that? Well, you all know that 10 squared equals 100. If I were to write that in logarithmic form, I would write that as log base 10 of 100 equals 2. Notice that the 10 here is the base of the exponent, and here 10 is the base of the log. We read that as log base 10 of 100 equals 2. Notice that the logarithm equals the exponent, which is 2. A couple of other things I want you to know about logarithms is what's called the common log and the natural log. The common logarithm is log base 10. So we often just write log of 100 equals 2. The base is assumed to be 10 when there is no base written there, just as when we write the square root of x and the cube root of x and the fourth root of x. The square root is just assumed to be 10 when we write radical x because that is the most common radical. The other type of log is the natural log. The natural log is abbreviated ln. Natural log of 5 equals x. I don't know off the top of my head what the natural log of 5 is, so I'm just going to put x in there. Natural log stands for log base e. Log base e of 5 equals x. So that means e to the x power equals 5. What is e? E is a number like pi that is a non-terminating, non-repeating decimal. Its first 5 decimal places are with its first 5 decimal places, the number is 2.71828. This number is very commonly used in mathematics, as is pi. So we need to be able to go back and forth from the exponent form to the logarithmic form, and you need to know if you see log without a base, it means log base 10, and if you see natural log ln, it means log base e. Now we're ready to get started on some of our problems. So if you go to the page in your notes, or if you look down at the group of problems, you'll see 2 groups of problems that are coming up next. 1 through 6 has problems written in exponential form that we want to convert to logarithmic form, and 7 through 12 has equations written in logarithmic form that we want to convert to exponential form. So I'm going to do a few of them with you and then ask you to do some on your own. So we're going to do 1, 2, and 3 together, and then I'll pause and let you do 4, 5, and 6. And then we're going to do 7, 8, and 9 together, and I'll pause and let you do 10, 11, and 12. So let's get started with 1, 2, and 3. So number 1 says 10 to the 6 equals 1 million. I want to write that in logarithmic form. So here's the base of the log. It's the base of the exponent, so it's the base of the log. So we say log base 10 of 1 million equals 6. Now some of you are screaming in protest now saying, I don't have to write the 10 because that's a common log. You're exactly right. I could just write that as log of 1 million equals 6 because that is assumed to be log base 10. Now let's look at number 2. Number 2 says 8 to the 1/3 power equals 2. That's the same thing. Now just to remind you, what is 8 to the 1/3? 8 to the 1/3 is equal to the cube root of 8. So the cube root of 8 equals 2. That makes sense. We understand that. Okay, let's put this in logarithmic form. Log base 8 of 2 is equal to 1/3. Now, just in general, If you notice that the base is less than the number inside the log, then your exponent is going to have to be less than 1. Okay, because 8 to the first is 8. 8 to some number bigger than 1 is going to be a number bigger than 8. But if this number is actually smaller than 8, then this number is going to have to be less than 1. Just a little tip for you. Number 3, 5 to the negative 3 is equal to 1 over 125. Once again, just as a reminder, what does a negative exponent do? A negative exponent does not make a number negative. It tells us to take the reciprocal of the base and apply the positive form of the exponent to it. So 5 to the negative 3 means 1 over 5 to the third, which would be 1 to the third over 5 to the third, or 1 over 125. And so that's what 5 to the 1/3, that's what 5 to the negative 3 means. So writing this in log form, log base 5 of 1 over 125 is equal to negative 3. So once again, here's another case where the answer is less than the base, so this number here has to be less than 1. In this case, it's actually even negative. Okay, you do 4, 5, and 6 yourself. Pause the video and then restart it to check your answers. Okay, here are the answers to 4, 5, and 6. This should be log base 10 of 2 equals 0.31010, or just log of 2 equals 0.3010. I want to point out something to you. If 10 to the 0 equals 1 and 10 to the first equals 10, then what power do I have to raise 10 to in order to get a number between 1 and 10? Well, I'd have to raise it to a power that's between 0 and 1. So if I am trying to say 10 to the what power equals 2, that power is going to have to be something between 0 and 1. So that makes perfect sense. Here, e to the fourth equals 54.598. So I say log base e of 54.598 equals 4, or natural log of 54.598 equals 4. Now don't say ln base e. It's either log base e or natural log ln. Don't put both on there. Then this is log base a of c equals b. Hope you did all right on those. Okay, let's now go to the next section of your problems. Okay, now we're going to look at numbers 7 through 12, and I'm going to get a separate page so that I have a little more room to write for 7 through 12. Okay, number 7 is log base 6 of 6 equals 1. So thinking of my little swoop, I don't remember if I told you about the swoop yet, but I think of this as 6 to the first equals 6. So I kind of swoop over from the base to this exponent equals this answer. So 6 to the first equals 6. Number 8, log base 5 of 25 equals 2. 5 squared equals 25. Number 9, log base k of a equals c. K to the c equals a. Okay, now you do numbers 10 through 12. Pause your video and then check your answer. Okay, 3 to the negative third equals 1 over 27. Remember, 3 to the negative third is 1 over 3 to the third, so that's 1 over 27. E to the negative 0.51 equals 0.6. 10 to the negative 1 equals 0.1. So remember, on both of those you have to remember a natural log is log base e and log is log base 10. Okay, now to the next section of the problem. In this next section, I'm going to do certain problems, the ones highlighted in yellow, along with you, and then leave you to do those others yourself and then check your answers. So let's get started. on number 14. Number 14 says natural log of x equals -1. Whenever we have something written in logarithmic form, I want to convert it to exponential form in order to solve. And when something's written in exponential form, I want to convert it to logarithmic form to solve. These are all in log form, so I want to convert them to an exponential function in order to solve them. So I think of this as log base e of x equals -1. Then do my little swoop. E to the -1 equals x. What is e to the -1? 1 over e. Now I could also get a decimal form of that, but this is sufficient for the answer. So 1 over e equals x. Now the next one I wanted to do is number 17. Number 17 says log base x of 2 equals 1/3. So x to the 1/3 equals 2. Well, x to the third means the cube root of x equals 2. So what do I do to solve that? Raise them both to the third power. So x equals 2 to the third, which is 8. The next one I want to do is number 20. Number 20 says log base x of 1 equals 0. So x to the 0 equals 1. When you look at that, any number to the 0 equals 1, doesn't it? So x could be any real number, but let's look at the original problem. This is something that you don't know about logs, but x, when we do logarithms, the base can't be negative, so we don't have a negative base. So x is not a negative number. If it's 0, it's undefined. So we know that x has to be greater than 0, because 0 to the 0 is undefined. So it can't be 0. Log base can't be negative. So I'll say less than 0. And then the other thing is the log base can't be equal to 1. Let's think about that. If we have log base 1 of 3 equals x, we say 1 to the x equals 3. Is that even possible? No, the only thing possible is 1 raised to any power is 1. So you really couldn't do much with log base 1. So we say x is greater than 0, x is not equal to 1, and that's the answer. It's all positive numbers that are not equal to 1. I should say all positive numbers that are not equal to 1. Okay, then I wanted to do a few more with you. Let's see, I wanted to do number 23, I believe. No, 17, let's see, 14, 17, 20, and I think if we do one more, we should be fine. Let me do number 23 with you. So number 23 says natural log of x plus 1 equals 0. So natural log, remember, is log base e of x plus 1. That equals 0. So e to the 0 equals x plus 1. Well, e to the 0, any number raised to the 0 is 1. So 1 equals, I think I copied that wrong. It's supposed to be x plus 4. All of you are screaming half point at it right now. So 1 equals x plus 4. So -3 is equal to x if I subtract 4 from both sides. So x is -3. Okay, finish the problems in that section. Pause the video. Right now, finish the problems in that second section and then check your answer. Okay, the answer to number 13 is 9. 14, 1 over e, we did that. 15 is 4. 16 is 2. 17 we did. 18 is 3. Take a look at that one's a little bit tricky. 19, not possible. If you were wondering what in the heck was going on with that, it's not possible to have any value, any exponent on 3 that would give me -3. You can't take the log of a negative number. Number 21 is 3. Number 22 is 7. And number 24, also a little bit tricky, 1 over 25. So check your work on those, make corrections if you need to, and then continue the video. This last section is a little bit tricky, so I'm going to go through these together with you. And if you, at any point you think you can do them on your own, go right ahead and work on them and work ahead. I wrote that wrong. 3 to the log base 3 of 4 equals what? Whenever you are supposed to just simplify an expression when it involves logs and exponents, a good tip is to just make it equal to x, because really what we want to find is something that's equivalent to this. So just make it equal to x, and then think this is in exponential form. Let's put it in logarithmic form. My base is 3, so I say log base 3 of x equals the exponent. And the exponent in this case is log base 3 of 4. So now I end up with log base 3 of x equals log base 3 of 4. Well, obviously x has to equal 4, or these won't be equal. So what we say here is log base 3 of 3 to the 4th equals 4. Notice that we have the bases are the same. The exponents have to be the same. So 3 is the base of the log, 3 is the base of 3 to the 4th, and so the exponents are the same. What I'm saying on this problem is if I raise 3 to let's see, this is so confusing to say, but let me try to say it. What this exponent is saying is it represents the exponent that I have to put on 3 to get 4. In other words, what exponent do I have to raise 3 to in order to get 4? So if I raise 3 to the exponent that I have to raise 3 to in order to get 4, what am I going to get? 4. If I raise 3 to the exponent that I have to put on 3 in order to get 4, I will get 4. A little bit confusing, but hopefully you'll kind of get the hang of this. Okay, let's look at number 26. 26 now is a crazy log one. Log base 5 of 5 squared equals, I'm going to put x here, and then let's write this in exponential form. 5 to the x equals 5 squared. Well, obviously then x has to equal 2. So this is saying if I take log base 5 of 5 squared, in other words, what exponent do I have to put on 5 in order to get 5 squared? Well, it would have to be 2. 5 squared has to equal 5 squared. I think this one's a little more obvious than that one. So x has to equal 2. Okay, let's look at 27 now. 27, natural log of e. You're going to be seeing this a lot. You're going to be seeing this a lot. So let's think about what is natural log of e. Well, let's write this as log base e of e equals x. So e to the x equals e. X is 1. So I want you to remember that natural log of e equals 1. That's a very important thing to know. Natural log of e equals 1, because anytime you see natural log of e, you can simplify it to 1. And that's very handy in a lot of problems that we solve. Okay, let's look at 28. Natural log, or log base 2 of 2 equals, well, if log base e of e is 1, then log base 2 of 2 is 1, because 2 to the first equals 2. So if the base and if the log base matches the number in the log, then we're saying it's 1, because we're saying what exponent do I have to put on 2 to get 2? 2 to the first is 1. Okay, let's look at 29. Log of 10 to the negative 2 equals x. So we're saying log base 10 of 10 to the negative 2 is equal to, I think you're seeing the pattern now, negative 2. 10 to the negative 2 gives me 10 to the negative 2. Number 30. E to the natural log of 5 is equal to x. So so this is an exponential form, so I need to put it in log form. Log base e of x equals the exponent natural log of 5. Or natural log of x equals natural log of 5, so x equals 5. So this is saying if this natural log of 5 is the exponent that I have to put on base e in order to get 5. If I put on e the exponent that I have to put on e to get 5, I'll get 5. So x is 5. If the bases match, and the bases do match here, e and base e, 5 and 5. Okay, I'm going to skip and do number 33, and I'm going to come back to 31 and 32 because they are kind of the basic principles of all this. So let's skip to 33. 33 says natural log of e to the third. We'll say that equals x. That's the same as log base e of e to the third equals x. We've done that a few times, so you should recognize that that's going to equal x is equal to 3, not 3 is equal to 3. So x is equal to 3 because we're saying e to the x equals e to the third. So it has to equal 3. Now let's look at the basic principles that we see in 31 and 32. 31 says log base p of p to the k equals, I think you recognize that is k. If these two match, these two match. 32, because this is saying p to the k is equal to p to the k. 32, b to the log base b of r equals r. Bases match, what's inside, the answer matches. Because I could write this as log base b of r equals log base b of r. Okay, so if the bases match, the exponents match. If the bases match, the answers match. Okay, that's the end of our log basics. Now you should be able to do more of this on your own the next time you see these things.